Okay. Unfortunately, I didn't have a camera on while I explained all this. We start with Q equals KA times X over L. We want to solve this for A. I've done this in 1, 2, 3, and actually 4 ways. Because there are many ways that we can proceed through the problem. So we can start by dividing both sides by K, if we would, just picking on the K. And we get Q over K, well, equals the right-hand side over K. And the right-hand side can then be written as K over K times then A times the quantity X over L. And K over K is 1, so we don't need to write it anymore. We end up with this. And this justifies the cancellation because K is a factor of the numerator, it's a factor of the denominator, as illustrated by the fact that we factored it out of the numerator and denominator. Okay, now at this stage, we go this way, we go this way. Well, let's do this first. Okay. I multiply both sides by L over X. I'll get rid of the X over L. So I do that, multiply by L over X, multiply by L over X. Remind myself that this can be written as A times X over X times L over L, X over X, L over L. So that would justify cancellation. We get A equals QL over KX. Now, alternatively, at this point, at least one person did this. We've got this, we divide by X over L. So take this route, we divide both sides by X over L. Clearly, X over L divided by X over L is 1. It leaves us A. And then Q over K divided by X over L is the same as Q over K times L over X. And there we have it. And then we just remove the parentheses and we get the same thing that we got here. So whether we multiply by L over X or divide by X over L, it turns out to be the same thing. And you want to think about why that's totally equivalent, because it can help you save a step or get a more obvious solution in some cases. But there's nothing at all wrong with this solution. There's nothing at all wrong with this solution. They're all equally good. Now, another thing we can do is we can say, well, this is the same as KA times X over L is the same as KA over 1 times X over L. And we get Q equals KAX over L. And then we multiply both sides by L. Okay, I write that as L over 1 over here because we have a fraction. I want to be very explicit about that because people really need to see that. Not everybody does, but we're going to look at it anyway because this justifies this stuff. Okay. The KAX over L times L over 1, what if people want to cross these out? Well, it's valid in this case because L is a factor of the numerator and a factor of the denominator. But we actually write this as KAX over 1 times L over L. And if I multiply out the numerators, I get KAXL either way. I get L in the denominator either way. So this is equivalent to this. L over L is 1. And we justify. We can cancel. Okay, so anyhow, without too much losing train of our thought, we multiply by L. And we get QL equals KAX because the L going to divide out. Okay. Then we divide both sides by KX. So dividing both sides by KX, well, the K is a factor of the numerator and denominator. The X is a factor of the numerator and denominator. We could write this if we wanted to. K over X over KX times A over 1, verify that the numerator and the denominator are the same either way. And now K over X is 1 for 1 times A over 1. Well, that all gives us 1. And A is QL over KX. We can even combine all this stuff. So if we rearrange this as we did here, the Q equals KAX over L, we can multiply both sides by L over KX. Multiply by L over KX. Then we're going to have an L divided by L. We're going to have a KX divided by KX, just as we did here. And we see immediately that A is QL over KX. So this is the shortest solution. It's the most direct. These solutions have a lot of value. They're all valid. And these solutions show us some details of why we can do some of the operations we do, especially reinforcing how cancellation works and why it works. Okay, so now we want to solve this equation for X. Let's see how we can do with this. Okay, well, first thing we notice, we're trying to solve for X. And there's an X on this side, and there's an X on this side, right? We want all the X's to be in the same side to try to solve for X. We're used to that idea. And if there are numbers, we know exactly what to do. Okay. So what we need to do is, first of all, we want to use the distributive law. Okay. So we want to isolate this to, well, we want to get a X term that's not in the parentheses anymore. So then we can operate on it. So we get AX plus B equals 2CX minus CD. Okay. It doesn't matter what order you write. If you write DC, it's fine. Okay. Now that we have this, we can subtract 2CX from both sides and end up with the X over here. And while we're at it, we can subtract B from both sides. So the only terms we have over here are terms that have X's in them. So let's do it the way we'll seem to like to do this. Okay, we'll add this equation to this equation. And we get AX minus 2CX. And we have a B and a negative B. Well, the B and the negative B go away. And B and negative B add up to 0. So you don't need to write that down. And then 2CX minus 2CX is 0, but we're left with the negative CD and the negative B. And we can write those two terms down in either order. I happen to write it down in this one. At this point, what can we do? Well, we're going to talk about it just a little bit. Okay, so at this stage, we kind of get stuck as what can we divide by here? Get rid of all this. Everything gets all mixed up if we look at this and ask, what can we divide by? Okay, so instead of trying to figure out what to divide by here, we've got an X here and an X here. We can factor out the X. Then it'll be obvious what we can divide by. So factor X, we get X times A minus 2C equals negative B minus C. Okay, so we have people trying to figure out what to divide by here, and to their credit, they weren't getting anywhere with that because they knew it wasn't going to work. Okay, that happens in algebra a whole lot. Okay, and if you just go ahead and divide by, like, try to divide by, well, you could actually divide by A minus 2C, but you're not going to see that until you factor. Okay, so now we divide by A minus 2C over A minus 2C. If we have it here, it's not clear that you can divide by A minus 2C. You don't even want to do it, and you didn't. Okay. As soon as they said, well, factor out the X, then we made it. It's all okay. Yeah, then you know what to divide by. Okay, so we get negative B minus CD over A minus 2C, so that X equals what we have here, okay? Now, it's not exactly a trick, but it's something you gotta remember to do. Remember, you can always factor out that X. And of course, when you start here, after you've done a few of these, you get the idea, okay, let's see. You have to get all my X's one side, then I'm gonna be able to factor out the X, put everything else on the other side, and it's gonna work out. Okay. So, that's very good. Okay, now. We get any solution is a good solution. Okay. Some solutions are better than others because they're easy. And we want the easiest possible solution without, of course, skipping or violating any rules. And so. Make sure I've got. It's Vegas over here. Okay. Okay, so our first impulse, along with what we did here, and this is good, we could use a distributive law. Okay. Then we could subtract the three-fourths BZ from both sides to give us Z minus three-fourths BZ equals three-fourths C. Then we can factor out the Z. So that okay. Now, what are we going to do about this? We got complex fractions. We got a fraction in the numerator, we got a fraction in the denominator. Okay, well, we can put this whole denominator over the same denominator, which would be 4. Okay. We can do a number of other things. It can get a little bit complicated. Okay. Uh-oh, we gotta simplify. Okay. Yeah, well, simplifying this isn't too difficult, depending on how you approach it. If you think of put the denominator over common denominator, put the numerator over common denominator. Well, yeah, we can do that. I'm gonna do it without going through the steps. And 1 is the same as 4 over 4. We got 4 over 4 minus 3b over 4, which is 4 minus 3b over 4. And this equals 4 over 4 minus 3b times 3/4 speed. And now we see that the 4 is going to be divided by the 4. I'm not going to be real explicit about how we verify that. 4 is a factor of the numerator, 4 is a factor of the denominator. So we could write 4 over 4 times a bunch of other stuff. But we end up with 3C over the quantity 4 minus 3B. Okay. Now, A lot of this, matter of fact, most of it could be eliminated very easily. If we do the one principle that I want to keep emphasizing. I don't know if I'd really call this good. This is okay. All right. This isn't quite a solution because it's not simplified. We want to avoid as much pain as possible. So, really don't have room to write that properly. That makes one. Next, let's start over. We got Z. Equals same equation. Okay. What do we see? I don't know what you see, but I see a denominator and I don't want to work with a denominator. So I'm going to multiply both sides by 4. We've got a denominator. Better yet, it's a non-zero denominator. It's not a variable. It can never be 0. The denominator is 4. Okay. We're going to multiply both sides by 4. We get 4 Z equals 4 times 3/4 times BZ plus C. I want to do this, get more. With my parentheses anyhow, 4 times 3/4 is 3, right? So that's 4/1 times 3/4 times BZ over C. And then 4Z is 3 times BZ plus C. And the rest, no different than what we've done in previous examples. So go ahead and finish it. And see how this makes the solution a lot simpler. Okay. Well, at this stage, everything proceeds as it did in the previous example. We use a distributive law. We subtract equation -3, add the equation, let's say -3BZ equals -3BZ to get 4Z minus 3BZ equals 3C. Then we have to remember to factor out Z. And we divide both sides. We get Z equals 3C. Four minus 3B, the same as we did for here. Now that's still a number of steps. It's easier to think through that than what you have to do to simplify this. Although you should be able to do either, you should be able to simplify that, but it's less painful. Steps are very straightforward once we get rid of the denominator. Okay. Okay, well, That's pretty good examples of the things that can happen when you're trying to solve formulas. Okay, I'm going to move quite a bit ahead here because we really need to get into intermediate algebra as quickly as possible. Since that's subject matter of the course. The way I have assignments set up allows us to spend almost half the semester on elementary algebra. Because in most cases, people need that. They really don't know much more than maybe a little pre-algebra, but they're trying to be in an intermediate algebra class. And usually if we've got a dozen people in class, 8 of them don't know elementary algebra very well. Okay. So we're never going to get them through intermediate algebra unless we spend a good bit of time on elementary algebra. Then once they get it, we can actually cover the intermediate algebra pretty quickly. We don't cover as much as we'd really like to. But in a class where I think everybody has the background where we can do well enough in this class to be able to skip the MDE 61 and safely go into a pre-calculus class, it's to benefit if we do that. Okay. So as long as everybody can keep up with the pace, that's what we're going to do. So far, yeah, I'm pretty pleased with what I've seen. Okay, so let's just take the equation or the function y equals x squared. I'm just proving here. Let's see what we can do with this. Okay, and this kind of tells a little bit about arithmetic. Can we evaluate y, which is of course equal to x squared, for each of these values of x? Can we complete that table? Okay, now this is something I assume everybody's seen before, because this is something you see in elementary algebra. But still, I'm going to work it out in detail in case it's somewhat foggy for some people. Okay, so x squared, of course, is x times x. If x is -2, we have -2 multiplied by -2. 2 negatives, so it's positive, and 2 times 2 is 4. Okay, then we have -1 times -1. Well, clearly that's 1. And -1/2 times -1/2. That's the same as 1/2 times 1/2. Since we have the 2 negatives, we don't need to write the negative. And then we multiply the numerators to get 1, and we multiply the denominator to get 4. 0 squared is 0 times 0, and that's 0. 1/2 squared is 1/2 times 1/2. And I'll write it out even in more detail than I did here. That's 1 times 1 over 2 times 2, which is 1/4. And then 1 squared and 2 squared. Yeah. Right down. Write it down too fast. And hand goes in automatic. Doesn't give my brain time to engage. Okay. So there we have it. Now we can sketch the graph. We can sketch these points on a graph. I'm going to anticipate a little bit. Okay. My x values go from -2 to 2, so I'm going to put -2 over here. I'm going to put 2 over here at an equal distance on the other side. Now to mark off a graph, I'm going to do this. I'm going to divide this interval in half the interval from 0 to 2, if I divide it in half, that tells me for 1 ought to go. And if I divide that in half, that tells me where 1/2 ought to be. And then I can do the same thing on the left side. Then I've got a pretty good scale. Let's see. Yeah, this two is a little bigger than this two, but not much. So it's going to give us a pretty true graph. Then I see that my y values go from 0 to 4. So I divide that into 1/2, which is a little hard because I'm looking at it from that angle. But so I get 2 here. I get 1 here. And of course, I could put my 3 in here if I wanted to. And then I get my 1/2, which is halfway between 0 and 1. And 1/4, which is halfway between 0 and 1/2. The fourth is half of a half. And I don't bother labeling these things, are going to get a little crowded there. So it's implicit if I do these carefully. Then I locate my points. Okay, when x is -2, y is 4. So I sketch purple line here, which is the line for x equals -2. I sketch the line y equals 4. And where they meet is the point -2, 4. And then I can sketch the line and I'm going to label it there. My curve's going to go through and do that. Normally, I leave myself room below. I didn't have a lot of room below. I chose to squeeze the graph in here. Maybe that wasn't a great choice, but okay. I did it, so I'm going to live with it. So we've got x equals -1 here along this line, and y equals 1. Along this line, and where they meet is my point 1, -1. I'm sorry, -1, 1. Then x is -1/2. And there's my dotted line for x equals -1/2. And y equals 1/4. Those two lines meet at this point. Then I have 0, 0. Of course, x is 0 and y is 0. X is 0 on the y-axis and y is 0 everywhere on the x-axis. So I've got these points. Now, I can draw my lines for x equals 1/2, x equals 1, and x equals 2. I've already got all the y's that I'm going to need. I've got 1/4, 1, and 4. So that works out kind of nice. Let's save it a little more. And there I get additional points. And I can connect these points with a nice smooth curve. And that's the graph of y equals x squared. It's a reasonable graph of y equals x squared. Then I'll just throw in Well, I was gonna throw in one little blurb, but I'm not going. Okay. It'll come later. Okay, here's a little bit about f of x notation, because the assignment on graphing uses f of x notation, but it doesn't really use it. Sort of uses it, okay? So let's make a table and graph y equals 1 over x, except we're not going to call it y, we're going to call it f of x. It's still y, but we're calling it f of x. Now, there are good reasons for f of x notation. It allows us to talk about a function without actually writing out its formula every time we want to say something about it. And it gives us a calculation scheme for evaluating a function that I'll explain in brief. But what it comes down to, as far as graphing, we start with a table. Here's x, and here's y. Well, we got the expression 1 over x. That's the expression that we're graphing. So I'm going to write it out as just y equals f of x, but f of x is just 1 over x. Okay, so all we're doing is same thing we're doing here. Same thing we did here. I could have written, instead of y equals x squared, could have called this f of x. And it wouldn't have made any difference. I was still evaluating all these points, okay? Now, where f of x notation gets interesting is if we did y equals f of x plus 5. Okay, so we could do that kind of thing, but we're not doing it here. We're not doing it in the assignment introduction to graphing. So we're just going to treat f of x as a label for this function. It's 1 over x, and we're going to use x values -2, -1, -1/2, 0, 1/2, 1, and 2, except we're not going to use 0. Are we not going to use 0? We're not going to use 0 because 1 over 0 isn't defined. Division by 0 is not defined. So we do the arithmetic, we get -1/4, -1, -2, 2, 1, 1/4. We're going to leave 0 in here, but I'm going to give that the label DNE for does not exist. And there's a good reason I do DNE. Now, I assume everybody can do the arithmetic of this. You have the arithmetic of 1 divided by -1/2. You've got to invert the denominator and multiply and use, again, the rules for fractions. And I assume everybody knows, but if anybody doesn't, please let me know and we'll talk a little bit more about it. Okay, so here it is. I do my graph. I'll do this graph fairly quickly. Okay, so here's Here's one. There's -1. Here's 1/2. And I'm not going to include. I'm going to put my -2 label up here. Put my -1 here. And my -1/2. I'm not going to write. Okay, so there's enough labeling on the graph that we tell what we have. Our point -2, -1/4. Okay, well, there's 1, there's 1/2. Divide that half in 2 pieces, and we get a 1/4. And do the same thing down here. And we see that we have the point -2, -4, -1, -1. And -1/2, -2. We've got these 3 points. And over here, well, we do the same thing. I'm not going to do it in detail. Actually, I got my -2, -1/2 a little bit too high. Change the shape of the graph a little bit. You do it carefully, though, you get the right shape. Okay. Now it's not totally important right now, but since the value for 0 doesn't exist, that tells us that we don't connect this point to this point. Because if we were to connect this point to this point, we would go through the y-axis. Wherever we go through the y-axis, that would be the value of 1/x when y is 0. And there is no value. So we don't cross the y-axis with this, because if we did, that would assign a value of 1/x to x equals 0, when that can't be done. Okay, the only thing I'm saying here is, really, the whole point of this is, yeah, this graph is easy enough to do. Right now, we just treat f of x as just the name of the function. And y is going to equal f of x, which equals whatever the formula for the function is.
One of all my favorite forms.